friends, so today we are solving find all k-distant indexes in an array. So we are given a 0 index integer array nums and 2 integer key and k. So a k-distant index is an index I of nums for which there exists at least index j such that I minus j is less than or equal to k. You can visualize a vector base here. For example, this is our nums and there is a one key is given to us and one k is also given to us. So here what will happen is whoever is coming to the range of whenever we are reaching to this key wherever, okay, then we have to have from the left side at a distance of 3 and on the right side at a distance of 3 we have to get all the list. Okay, so we can visualize, let's say we are traversing from here. Okay, this is our array, we are going here. So 3, this is 4, this is 9. So we found a key. Now from this key left side 3 times, right? Left side till 3 index, 3 distance, and right side also for 3 distance. We have to print all those indexes. Basically we have to take all those indexes into a list. Okay, so for example this is 0 which is coming in the range, 1 is also coming in the range, this guy 2 itself is also coming in the range. Similarly this and this, all these are coming in the range. Now you can observe one thing that this is 0, this is 1, this is index 2, right? So it index 2 minus 3, if you do for the left side, 2 minus 3 is going to become minus 1. So we have to start from 0 only, right? So we have to take the positive values only, we cannot take the negative values. Similarly for right side also, let's say we are at this point, right? So it will start from here, 3 indexes from the left side and 3 indexes from the right side, but our right side index only can go up to n minus 1, right? So we have to take care of those boundary cases. Okay, now we will discuss about one more scenario. Is there could be a possibility, for example, when we are reaching at this key we would already add these indexes, right? But when we are coming back here, this also, so that these are the ranges indexes, so we have to skip these indexes which are already added by some other key. Okay, so let's do the dry run of this code. So what we will do is we will start here. Let's say we have to take always, whenever we are reaching a key, that we are starting from here, we reached once a key. Let's say at I we found a key at index I. Then what would be the left side? Because we have to add all those range. So what would be the left side here? Left side would be I minus k. So I minus k. Now I minus k is, I is our 2, right? So it would be 2 minus 3, right? Which is becoming minus 1. So minus 1s are not the index that we have to take care. So what we will do is, in this case, initially we will make a variable integer r, let's say. So int r we will decide here, and this int r is basically, initially we are initializing it with the 0. So what we can do in this case is, whenever we are finding the left side index, we can do one thing. We can find the max of r and I minus k. Now some of you might have a question that why this r, why can't we make 0 only? Because it's a matter of 0, right? If we can make a max of minus 1 and 0, this will give us the start value 0. Then why this r, only? So why I am taking this r and started with the 0? Because if I put r equal to 0, it will take care of this case, right? Minus 1 and 0 case, because only once this case would be arrived when a key is occurred in the range which is going outside on the left side. So I am starting with r equal to 0, but remember, once we are done with this value, we also might get another key, right? So at that time we have to keep this r in such a way that till the r, all those left side, if they are visited, we will skip. Okay, so that is why we need, because next time also a key can occur. At that time also we don't have to add the duplicate values again. For example, let's say if I came to this key I would be adding one index, this index and this index both. But when I'm coming here, should we again add these indexes? No, right? So to keep track of those who are added, and then R would be the variable which would be having the indexes which are not visited. Okay, so that is why I am taking this integer R instead of going to 0. Okay, so left would be decided like this, that max of R and I minus K, and this R which would be the right side, so R would be decided with the min of what? So min of n minus 1, because right side we can only go up to n minus 1, we cannot go beyond of this array, otherwise there would be a exception. So this would be min of n minus 1 and I plus k, right? So it would be I plus k. Now I would be adding here plus 1. Now you might have a question that why plus 1 suddenly? What is the use of this plus 1? So I will tell you why plus 1. So first of all is we are getting the right left range we already got here, and right range we already got min of n minus 1 and I plus k. Then why plus 1? This plus 1 is basically indicating that up to this level we would be able to fill our indexes, but this plus 1 is adding to the next. So R would be having the values which are not visited, means the smallest index which would be not visited for the next key. Okay, so for that reason I am making this plus 1. Okay, now what will happen once we have got left and R, right, L and R, we have to add those range, whoever is coming in this range, we have to add them into the list. So what we have to do is here we can do the dry run for this code, this example itself. So let's do that. Okay, so suppose this is our answer list. Let's say I am calling it ANS. Okay, so in this list we will keep on adding the things. Okay, so yeah, so when we are coming from left to right, we would be keep on tracking when we occur this. So we are going from here, this is 3, this is 4, this is 9. So we got our I. So I is 2 here, right? So I is equal to 2, where the key is first key we have found. Now we have to find L. So what would be initially R equal to 0? When we reached here, R was 0. So 0 and 2 minus k is 3. So 2 minus 3, it is 1, right? So 0 and minus 1. So L would be, it would be 0 and minus 1, max of 0 and minus 1, which is 0 only. Okay, so our L is 0. How about our R? So our R would be here, n minus 1 is what? 3 and 3, 6 and 7. So n would be 7. So n minus 1 would be 6, because n is 7. So 6, and what is the I plus k? So I is our 0, 1, 2. So 2 plus 3. So I plus k, this is 5. So what is the minimum here? Minimum here is 5 only. So 5 plus 1. So our minimum, our R equal to now becoming 6, right? We got the minimum from here plus 1. So 5 plus 1. So this is 6. Now in this 1 and 6 range, including these, we have to add all these indexes, right? Because these are the values which are in the range of this. You can read here. We have to keep all those which are lesser than or equal to k, right? So we have got this range. So what we will do, we will add all those values starting from 0 till 6, right? So 0 will also include 1, 2, 3, 4, 5, 2, 3, 4 and up to 5, means whatever is there R minus 1. Okay, now this 6 would be the index which is not visited yet. Because of this, rest all are visited from the left side as well as from the right side. Now we are coming, when we are going ahead, this is 1. Okay, we will keep on going. This is 3, we will keep on going. this is 9. Again we have found this key. So for this what is the index of this key? 0 1 2 3 4 5. 5 is the index. So again we will keep on doing same thing, right? So what would be the L here once we reach at 5? So L would be R. What is the current value of R? R is 6. Okay, so 6 and this is our 5. So 5 minus 3 is 2. So what is the max here? Max is 6 here. Okay, so we got L equal to 6, right? And what would be the R value here? New. So it would be again n minus 1 is the 6 only, and I plus k, right? So I is our 5. So 5 plus 3, this is going beyond the limits, right? 5 plus 3 is 8. So we have to take the min. So min would be this 6, right? So we have got L equal to 6 and R also equal to 6. Now in this range, if we go, we have already added all those things, right? So only one value would be added here, starting from 6 and ending at 6. Only one index, 6 would be added here. Now we are done. This should be our answer. So let me show you my corresponding code for it. So see here what I'm doing. First of all, I have created an array list where we would park our values, and I have initially created R equal to 0, and then n is the length, whatever is the length of this num. Now see here, we are starting from 0 and till n. Whenever we found a key, num psi equal to key, just like we found here num psi equal to 9, because key is our 9. In that case, what we will do, we will take the left side, that what would be the range from where we will start. So it would be math.max of R and I minus k, because I minus k would be also in the range. Similarly for right side, we have to take like math.min of n minus 1, because up to n minus 1 we can go, and I plus k. And I'm adding this plus 1 because we have to keep track R for the next key, that this was the smallest index which is not visited yet. Okay, so we got once these range, what we are doing, we are doing that for I and j equal to L and j less than R. I have not making j less than or equal to R. I have made j less than R because R has plus 1 added. So then j plus plus. So we are adding all those indexes into our array list. And this for loop keep on going, because for next time if another key occurs, again we would be doing same thing, and we would be adding only the non-overlapping within range indexes into the array list. So let me execute my code. We are doing this code in the single traversal without any extra space. So let me try to submit it. So I am submitting it. So it is 97.25% faster. So we are using O of n, time complexity, and no extra space. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.